All right, here we go. This is problem number 19 from chapter 6 of the Halliday and Resnick textbook. So the idea is we've got this box. I'm going to recreate the drawing here. And it's being pushed against a wall, right? So it tells us that the force that we're using to push the box against the wall is 12 newtons, okay? Now, it tells us that the block weighs 5 newtons. So for that to make sense, you need to think about the definition of weight. So remember, weight, by definition, is the force of gravity. So that means that I've got the force of gravity pulling this thing down here, 5 newtons pulling it down, right? Okay? Now, we also know that the coefficient of static friction is 0.6, and the coefficient of kinetic friction is 0.4. So, what other forces act on this thing? Well, let's see. We're pushing the block into the wall, but obviously the block's not going to go through the wall because there is a normal force. So this is a weird example. Our normal force is, this time it's not vertical at all. It's purely horizontal. Remember, your normal force is always perpendicular to the surface of contact. Okay? So my normal force here is going to be 12 newtons, right? And so the idea is, hopefully, there is enough friction, hopefully enough static friction, to prevent it from moving. And if not, then we'll switch to kinetic friction and find the acceleration of it moving down the wall. Okay? So let's find our maximum force of static friction. So our force of static friction max, well, that's just equal to our coefficient times our normal force. So our coefficient of friction is 0.6. Our normal force is 12 newtons. Multiply that and you get 7.2 newtons. So we've got gravity pulling down with 5 newtons, and static friction can exert up to 7.2 newtons to prevent the motion. Oh, so we're good. I can put a static friction force here of 5 newtons, and my drawing is done, right? And that's going to give us an acceleration of 0. So does the block move? No. Okay. Now, just to be clear, if this coefficient had been smaller, like say it had been 0.4, for example, if this coefficient had been 0.4, then we would have only had 4.8 newtons of static friction, and it would have accelerated downwards. And then we would have had to have switched to whatever our kinetic friction was to find the acceleration. All right, now B, this is super sneaky. I remember solving this problem and being, I kind of had to think a little bit about part B. All right, so B says in unit vector notation, what's the force on the block from the wall? So the idea here is the normal force is definitely a force provided by the wall, right? But so is the static friction, right? That static friction is friction between the block and the wall. So it's the wall's friction, I guess, is preventing the downward motion, okay? So the wall, thus, is exerting 12 newtons in a negative I direction and 5 newtons in a positive J direction. Okay? So that's the deal with part B. All right? Hope that helps.